to understand, to re-elaborate, we have started with inheritance in during our last lecture, and this lecture we will carry over some of the concepts and which we did not understand, I mean we did not cover during the last lecture. So when we talk about this derived class, as we mentioned in the last lecture, and then specially redefine the function. So basically we are talking about this scenario. I mean, let's say here, let's come here because I have not started discussing about the new one yet. So we are talking about this scenario. You have a base class, class base, I mean, whatever the contents are there, and then you have a class derived or D, I'm saying D for derived. Then we put a colon and then we say class B. So that means base class is implemented into derived class. So basically the derived class is class D is derived out of the class B. So it will contain all the functions. The class B will inherit by the law of inheritance in C++. This will inherit all the functions. I mean, according to the access, according to the access criteria that we already talked about it. Like if we think public, that offers the most generic type of inheritance, most generous type of inheritance. But basically, if you, what we were trying to talk here, suppose you have a function called int x. Now, I mean, of course, it has a return type, but I'm not going into the body of the function, just the signature of the function. And if you define int x, and then if you define int y, then you know what happens. Basically, in the main program, sorry, not int y, another, the same function is there. So this is called redefinition. And by doing the redefinition of int x, if you instantiate this class, class B, class D, I'm sorry, class D, and then if you call D dot x, then you know what happens. I mean, basically this function, although this one inherits the class B, the one in the derived class is ultimately called. Okay, so that's basically the implication of redefining the function. Now we are extending that concept. Now we are pouring some confusion within the whole picture. Suppose you have a base class, okay, and we define functions x and y. And now within the function x, we call y. I mean, I'm complicating the situation. Now, as the next step, the derived class inherits from base class. That's true. And redefines the function y. Like we redefine it. Now the object D of the class, derived class, is created and function x is called. When x is called, question is which y will be called? Will it call this y or that y? So to know that, let's do some live coding. So let's not this one. Let me open it up. 1 second. So classwork. Yeah, it's coming up. So yeah, we are right on the spot. So we have the base class. We have the um, do something method. Let's say we are defining something else here. Let's say we are defining void x. and we are calling y here. We have not defined y yet, and then we can say void y cout. We are in base classes y. Okay, so we can make it, this is public, so we don't have to worry about it. Then in the derived class we can do the same thing, exactly same thing, you know. um, you can basically define the x and y in the same way. Just a second, what happened to it? You can define x and y in exactly same way. So just one sec. Yeah, you can define x and y in exactly same manner. So then the question is how the whole situation will uh, play out. So let's say we can define here in the derived class, it is the constructor, and now we can say that just as it says, derived class inherits base class and redefines the function y. Okay, so let's say we do here, where is the derived class? Here is the derived class, and we do void y, and we can say that cout, this is derived classes y. Very nice. So if we do that, and of course we have to save the code. Now the question is, in the main function, let's say I'm calling object x. Then the question is, which y will be called? Let's see which y is called. I mean, let's do it. I mean, rather than guessing the things when you are programming something, your best interest here is to run the program and then you try to understand what the heck is going on and where it is going on. So let's do this. G++ dash O, then let's say um, uh, confuse .exe, the confusion, I mean, because it's a double-ended question. So let's do inheritance demo. Yep. So if we do that, and then if we run confuse.exe, you can see that we are not calling this one. I mean, we are not calling derived classes y. So what happens here? I mean, if you think about it, the way the code is working, I mean, it is first, it is instantiating the derived class as the object. This is the object is the instance of the derived class, or object is the object created by instantiating the derived class. Now, once you do that, here, let me bridge the gap a little bit. So, yeah, once you do that, you see here that derived class is, I mean, this class is derived out of the base class and within the public scope. So that is the most generous um, derivation. Now you can see here all functions are public, so we don't have to be very critical about what is going on and what is not going on in the access control part. So here you have y, but this class also has y, and sorry, x. That x come from here in the base class. That's the definition of inheritance. Now, so if I am within this class, I may think that, well, I'm within this class, so whenever I call y, I should call this one. I mean, the program should call this one, but this is not actually happening. So what is happening here is when you go to x, then you are in the base class. You are using the x, and x is defined only within the base class. So you are tied with the base class and instance of the base class, and you have the y there. So basically this x is bound with the y which is associated with this class, this instance of this class when you create the instance. So this is called a static binding. I mean, you are not extending the binding, you are extending the I mean, you are implementing or extending the functions, not the binding. That is the main thing. There are two things: functional and the binding, second part. But here the binding is entirely static. So that's why you are calling the y from the base class only. So that is the answer to this problem. When you which I mean, when x is called, which y is used, the one defined in base class or the redefined one in the derived class. So this is the right answer, the one defined in the base class. This is basically called, and this is called this property is called, property with the inheritance is called static binding. This is called static binding. So the static binding is illustrated here as well. So you can see the functional definition is written here. So, I mean, we will illustrate more on that, but we answered. I mean, we understood the static binding. I mean, in the most primitive form of inheritance, all we are dealing with the static binding. There is no dynamicity there. We will see how we can enable the dynamic binding later. So we are now talking about class hierarchies. A base class can be derived from another base class, and uh, so basically here class B is derived from class A, and then so class B is derived from class A and class C is derived from class B. So basically when you have this situation, class C has the properties of class B, of course, but then whether or not this one, I mean, this one has the property of B, I mean property of A or not, it depends on how it is extended. I mean, if you are extending it all public, then you should find all the public properties from A into class C. But if you make it private, then all the methods will become private here in the class B, and then that stops, those methods stop. So basically, the flow of the inheritance through the hierarchy is something like that. So let's say we are writing a program called graded activity. So we can write it up basically. So um, there are four programs basically: graded activity, final exam, pass fail activity, and pass fail exam. So let us create the classes one by one. So we have more perspective into it. So let's do one thing first. In order to control these many class creations, let's create a new folder called hierarchy. And within the hierarchy, let's keep on creating the classes so that we are not confused, we are not mixing things up with the rest of the stuff. So let's create a function called, let us say, we start with the graded activity. Let's define what happened to it, hierarchy, and then let's define new file we call graded activity dot h. It's basically a header file, and that can be like this. Simply we can put it like that. So you have this class definition, you have the protected variable called score. Score is protected, then that means this protected variable can go to the child class if your hierarchy is, I mean, if your implementation of the base class is within the public scope, which is the normal behavior, normal prediction. Now you have public, and then you put I mean, all the constructor is defined, score is initialized here. You have even another constructor where you can initialize score as per a value of your choice. You even have more, I mean, you have more functions in this class. So set score and get score. This is the mutator, this is the accessor. And finally, you have a function. You don't give any concrete implementation of that function. You just say it's a character, it's a return type is character, and the grade get letter grade. So there is no concrete implementation of this function. Very nice. So next step, as a next step, let's define, um, this is the graded activity. Let's define um, pass fail activity, another function. So let's create it. Dot h. When you say dot h, this is basically header file. So this class can be like this. So what you do here, you are implementing graded activity into this class. So if you think about the hierarchy, call hierarchy here. So you have the graded activity. This is the base class. And then you have the pass fail activity. This is the derived class. Okay. Okay. That's good. So now what are we doing here? So we again we have a protected variable minimum passing score. This is not something we had before. And then of course we have the public constructor, the default constructor, and we are extending, we are basically implementing the graded activities constructor into it, because it means that it will not just contain all the variables from this class as a part of the constructor. Everything will be initialized, like the ones in the score, basically in the graded activity, that will also be initialized. You have a overloaded constructor. So you have a double MPS, I mean a variable, and minimum passing score equals this, because you can change the minimum passing score. Usually nobody set minimum passing score to be zero. Like in any college environment, that can be 60, right? I mean, that's normal. So then you have the mutators, and it's pretty simple. Now in the past code, you had get letter grade to be constant. This one also shows get letter grade equals constant. So in one aspect you have overridden this function into this function, this pass fail activity. So that's it. And then let's code for the graded activity. I mean, let's implement those functions. So we have to implement only one function as a part of the graded activity, right? That is your uh, get letter grade. So let's code it under this folder. Let's create graded activity dot c. Sorry, graded activity dot cpp. So this will contain nominally this one. You have get letter grade. It was not defined. Now we are defining. Okay. So that's simple. So we have done this. Let's keep saving the functions. Otherwise, we will run into the similar kind of confusions as we had before from time to time. This is really annoying me. It is not letting me save anything. Let me save it irrespective of whatever it, oh, I think I can take care of it in this way. Okay, now everything is saved. So as we define, you can see that the scheme of the course it's given here. More than 89 is A, then if the score is more than 79 it's B, and so on. I mean, you can see the criteria, detailed criteria here. Okay, so now we have the graded activity and pass fail activity. We have to implement pass fail activity.cpp. It's simple. You have to just pass fail activity. You have only one function that is not implemented. Later grade, we have to implement that. So let's create the file pass fail activity dot cpp, meaning it's the C++ code. So what will contain in this code? Nothing but this one, just like your graded activity. So you have this one. So the get letter grade, but note that it is little different. If your score is more than minimum passing score, then you say P, otherwise you say fail. So it's not a multi-graded class, it may be a pass and fail class. In an university system, you can have multiple graded class or you can have just pass and fail class. That's it. So now what we can do, we have completed graded activity and pass fail activity. Um, we can even do more. Let's create another file called pass fail exam. So pass fail exam.h. So this can be um, like this one. So here what we have done, we are implementing pass fail activity into the pass fail exam. So pass fail exam is the derived class and pass fail activity is the base class. So you can see here our classes are running through different levels of hierarchy. So you have the base class, you have the derived class, and then you have further derived class, let's say 1 here. But now this class pass fail exam is derived out of this class as well. Okay, so we have the multiple generations of inheritance going on in this particular problem. So far so good. So you have this one pass fail exam.h. So you can see here uh, we have number of questions, points each, number of missed questions. Then you have the public constructor. It's extending pass fail activity. It means that whatever was there in the pass fail activity is also initialized at this point. Constructor is a function that initializes the data inside your class. So we are maintaining that, and then you have a overloaded constructor here. So you have the questions, missed questions, and uh, MPS, that is your, probably it's your uh, just your, I mean, where did it go? So pass fail activities. So pass fail activities here. Yeah, that's just a score possibly, or minimum passing score. Sorry, this one. And then we have a mutator function, set int, and we did not define it here yet. You have the accessor functions which are defined here. So let's define the mutator function as well. So to do that, let's do this way. So we can say passfailexam.cpp, create a new file. So once you do that, you can just use this one. So you have pass fail exam, and the set function is defined here. So you have two arguments, questions and missed questions. So numeric score is calculated here. So the formula is pretty simple. Numeric score is um, missed times points each, and your score is like that. So that's the set score. So 100 minus missed times points each. So it's basically 100 minus total point that you missed. That is the point you received. And that's how it is coded. So we are good so far. Now, if we simply um, create a main function, let's say main1.cpp. So note that what we have done, oh, not this one. So this one. So what we have done here, let me save this one first and then this one. Yep. So what we have done here, we are including pass fail exam. We are not including any other headers because those are already included within pass fail exam, and I mean they run across the inheritance hierarchy. So we don't need to reinitialize everything every time. So we got it there. So the main function, you have the number of questions, missed questions, and minimum passing score. These are the variables, local variables within the main function. Then we have the users to enter number of questions. Then they have number of missed questions. They have minimum passing score. Then you instantiate the pass fail exam in this way: questions missed and min passing. So you are calling one of the constructors, you display the test results. That's it. I mean, there is no other stuff, but we have to see what does it do. So let's run the code first, then we will go through that more. So G++, and then we can say, um, let's say we are doing graded activity.cpp G++ dash O. Um, we can do grading.exe, and then the function, the file name can be graded activity. Oh, we have to go to that folder first. That is hierarchy. Yeah, G++ grade.exe, graded activity.cpp. Then we have pass fail activity. Then we have pass fail exam. Okay, we don't include the .h files when we compile. So we have some bad news. We cannot. Oh, we have to use the main. We have the main, and then if we compile it, it compiles, and then we can start executing the program. And now we can see what's going on with the program. So grade.exe. So how many questions are on the exam? Let's say 100 questions. How many questions did the student miss? Let's say 10 questions. Enter the minimum passing score for this test. Let's say 60. Then we can see that each question counts this one. Student's exam score is 90, but the grade is P. You see here, the grade is exam get letter grade. So exam is the pass fail exam. So if we go to the pass fail exam, let's see what does it mean. The pass fail exam has this one. It has set score. So it's a set function. So it must have inherited something from the pass fail activity. Not pass fail activity. It should inherit the things from graded activity. So graded activity, you have the score. So the get letter grade. So we can go to the graded activity.cpp. The letter grade is this one, but then in the pass fail activity.cpp, we are recalculating that. You see here, we have this one, and then we have recalculated that one. Pass fail activity.cpp, and we have pass and fail. So the ultimate question is, when you run the pass fail exam, you know, then why the one in the graded uh, activity, I mean, why the letter grade from the graded activity is not called, but the pass fail activity is called. So that's the broader question. That's what we studied already in the base and derived class, but it's a bit more illustration. So if you see in detail what is the main function, you can see here that you have the pass fail exam. But so basically, what are we doing here? We are we are instantiating the pass fail exam class. So pass fail exam here, it does not have any graded activity. So it is basically inheriting that from the pass fail activity. And within the pass fail activity, here you have the letter grade class, letter grade object, I mean the function. So it is running this one, but not the other one. I mean the graded activity, it has also a letter grade class. It is not doing that. That's because of the static binding, because we call the function from pass fail activity, right? We are calling this class. So it will call the function that is associated with this class. Therefore, this is strictly a static binding and nothing else. Now, we can think about a different situation. Um, let's say we do things little bit different way. Um, we can come up with another main function. So let's create main2.cpp, main2.cpp. So another main function basically. So you have it here. So you again have the pass fail activity like main1. You got the pass fail exam, but here you see we are inheriting, I mean we are including the pass fail activity, not the second level. We are not considering the third level of inheritance. We are only considering the second level of inheritance, meaning uh, we are just calling this one. Okay. So if we do that, then here is what we find. So go to main2.cpp. So you have pass fail activity is instantiated here. So the minimum passing score, I set it as 70. It's not decided by the user, it's decided by the system. And you set the score to be 72. So you have to display the grade. So now let's do a little more mix to it. Dot main 2.cpp. So if you do now, oh, that's not right actually. We have to, then it will be having another confusion. Which main class will it call? So what is happening? Main2, right? Did we do this rightly? Main2.cpp. So your grade, why it is missing the, oh, I think we did not save it. You see, this is the main problem here. So if we compile it, then we can run it grade.cpp.exe, and you can see the letter grade is C, not pass or fail, because I mean, we are just calling this one pass fail activity. So the pass fail activity is here. So pass fail activity is here, but then what is going on here? Let's see. Some other stuff is going on, must be. So you have the main2.cpp. So here, oh, okay, display grade. So you see here, the display grade is derived from the graded activity. So I mean, when you do that, you are setting the test score, and then you do display grade, and then you have the test. I mean, this graded activity, and then you put the pointer. So it is deriving things out of the graded activity, which is this one. So that's why when you explicitly mention the class name under the reference, then you get exactly which function is bound with that particular class. So it is, that's why this is a demo for the static binding strictly. So that's what we have learned, right? I mean, we did show that there is a function redefinition. So that is simply a manifestation of polymorphism. But in this case, this is a strictly compile time binding or static binding. So let's give a quick break of 10 minutes, and then we will come back and we will discuss how we can make it a dynamic binding. That's why actually we are calling it a static binding. So let me reiterate. So we illustrated about the static binding during the last hour, and in that particular illustration we have shown that whenever you have a static polymorphism, the one we described, the which function to be called, if especially if you have a parent class where you have a function, you have a derived class, you have redefined the function, but then it really depends on from where you are calling, which class you are calling, and it will basically find out the function which is associated with the class that is being called. And that's why this is called static polymorphism or static binding. So let's move forward. Now we are going towards dynamic binding, and that's why we are going towards polymorphism and virtual member functions, because we will show that virtual functions are the ways to provide dynamic binding. And here is how we can do it. I mean, let's go through the remaining part. So we are going to define a virtual member function. So a virtual member function in the, I mean, the function in the base class, this is a function in the base class. That means the parent class that expects to be redefined in the derived class. What do we mean by expects to be? So here is how this is reflected. You write virtual, void, and this one. I mean, the keyword virtual is the key to this expectation. Now, these virtual member functions supports dynamic polymorphism or dynamic binding. So it is basically, when you say dynamic binding, I actually mean the runtime binding. It decides during the runtime which function to pick, to choose from. It's not defined at the compile time. Anything that is static, anything that is related to the static polymorphism is decided at the time of compilation. But anything that is dynamic, that is decided during the runtime of the program. So without virtual member function, C++ uses compile time binding or static binding. So always remember, when we talk about a static binding, when we talk about static binding, then we really mean compile time. And when we talk about dynamic binding, on the other hand, then we mean the runtime. During the runtime of the program, this binding occurs. So we have this function, right? I mean, we already coded this function. So you can see here we have this function. It's like part of the graded activity, and because the parameter in display grade function is a graded activity reference variable, it can reference any object that is derived from graded activity. That's the I mean uh, that's basically compile time binding. Now think about this one. I mean, the one we showed later. So there what we had, I mean, in that case, the later grade member function returns C. I mean, we have already seen that in our previous code. So graded activity classes, this function was executed instead of pass fail activity, because I mean, that's because you were calling the other function. I mean, you were basically pass fail activity object. That's why you were getting that particular particular grades, letter grade C instead of P. So we can, so this is not good, because we are getting two conflicting results if we simply alter. our class calling hierarchy uh, during in a calling hierarchy in a framework that we built for the graded activity based on the inheritance. So what we did there, I mean, let me share my code. We have to understand it very extremely correctly in order to uh, understand the full meaning of it. So you can see here, just a second. So in this program, you can see this hierarchy, the whole framework, I mean, whole bunch of code that we build here uh, in the hierarchy under the hierarchy folder. This is the framework, and here you can clearly see that we are basically guided by which class we are uh, implementing or which class we are instantiating. So we are executing a framework, and also if the framework of the scores are about the same, but still we see different results. We don't see pass or fail, we see some letter grade here, but in the other case we see the pass or fail. So that is not good. So we have to overcome that by means of virtual function. So let's move forward. So a virtual function is all about dynamic polymorphism or dynamic binding. At runtime, C++ determines the type of object making the call. So at the compile time, if it makes the call, then it is really attached to the class itself from where it is called. But at the runtime, if it determines the call, then it is going through a lot of links, the dynamic links within the code that we established, and the compiler can interpret, not the compiler, sorry, I mean the executable, C++ executable can determine where the binding actually lies. So so during the runtime, C++ can determine the type of the object making the call, and it can then associate the function to the appropriate function version, associate the function to the appropriate version of the class that we are calling. I mean, uh, appropriate version of the function, but um, I mean, it will know by definition that by the virtual keyword which one to use. So to make the function virtual, we have to place the virtual keyword before the return type in the base class declaration. So instead of doing just character letter grade constant, we do virtual. So we are introducing this virtual keyword to make it virtual. So the compiler will not bind the function to calls. So basically, so when you say virtual, compiler will stay away from any binding. Rather, it will let the program to bind them whenever they are running actually. So you can see, I mean, you can create and definitely create an updated version of graded activity, and there you will be able to see that if we make it virtual, then it basically supports the virtual binding. Okay, so we have the uh, graded activity. So let's try to code that. Let's try to start that part. I mean, rather than going through the slides, let's at least see on the IDE and try to compile it. So let's say I'm creating a folder called uh, virtual. So we know that we are talking about the virtual functions. No, not under hierarchy, but under uh, the the global scope. So what is going on? Can I put it there? Okay, no worries. Let's put it here in the global scope, not as a part of the hierarchy, but here, virtual. Yeah, now it's good. So under the virtual, let's create a function called graded activity. Just same functions, I mean same code, graded activity dot h. Okay. So the graded activity dot h would contain exactly the same thing as before, except one thing. That is, let me first close all so that only the one that I'm working with is displayed. So here you can see we have exactly same thing as before, but here instead of making character grade letter get letter grade, we are just making it virtual. That's the only change we have made. So if you compare with that, it's basically graded activity, so everything is same. That just here we put the virtual keyword. That's the only difference we have made. So let's remove that one, this one. This is good. So then we can do the graded activity.cpp. Let's complete that implementation as well. So let's create a file under virtual. So not hierarchy virtual, but here, this virtual. Let's create a file here and call it graded activity.cpp. And then we can simply use the implementation. I mean, there is no change here. It's exactly same as graded activity. And you can note that when you implement the function, you are no longer calling it virtual. Virtual is when you define the function here. But when you implement the function, you don't call it virtual. That's super important. Now, um, let's define the pass fail activity. Here also the same business. I mean, we have to define the function to be virtual. So let's say I write pass fail, sorry, activity dot h. So you can see, not this one. I have just copied the graded activity. So this one is blank. So I have to use this one. Yeah. So this is our pass fail activity. So I have to save the graded activity. So go to pass fail activity and see that we are doing like this. We included graded activity.h. Remember, .h stands for the header file. Now we have we are this is the in this case this is the child class and this is the parent class, and you can see that we are doing exactly the same thing, but this function is really virtual. So we are making these virtual as well. That means we are not doing any static binding anymore here as well. So then next logical step would be to define passfail activity.cpp. So let's define that. What is happening here? Yeah, passfail activity.cpp. So there we can, I mean, we have the same uh, same code. I mean, there is no difference between this code and the previous version's code. It is exactly the same. All the changes are in the header file. So we have implemented this function. Very nice. Now the pass fail exam. Let's define the pass fail exam as well. So did we do that here? Pass fail activity.cpp. Okay, yeah, we are doing that right. So now we can define another file, pass fail exam dot h. So for the pass fail exam dot h, we can do the similar, like similar header file. And here you see there is no concept of virtual function because we are not using the one, the letter grade here at all. That's pretty cool. Now I have to save it. Yeah, I saved it. Whenever the blue dot is not there in the top, that means I have saved the function, saved the code. So now let's code pass fail exam.cpp. Pass fail exam.cpp. Okay. So the pass fail exam.cpp would really be like this. So it's same as before. There is no change here as well. So I saved it, so it's good. Now let's try to interpret what is going on in different places. So let's start with this one. I mean, let's define a main function. So we can say under the virtual, let's define the main function main1.cpp. So here we can do this one. So this is the function prototype, and you can see we are calling the graded activity, but we are instantiating the pass fail activity, and this one the test score is. So if we now compile, so this should be under um, virtual folder g++ dash virtual.exe, and then we can say we can mention all the cpp file. Then um, what else is there? Pass fail activity. What else is there? Pass fail exam, and main1.cpp. If we unrecognized command line, oh sorry, so dash o, it should be dash o virtual exe. So that's good. Okay, so now if we execute this one, let's say we do virtual.exe, then you can see that we are no longer doing C here, we are doing letter grade P. So we have to find out, I mean, why it is calling the letter grade P rather than the, the 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 score. So basically we are doing the pass fail activity. Now how we are deciding that, that's something we'll decide, but we'll know. But basically it is producing the letter grade to be the P. So let's go to the slide to illustrate that. So now, as I said, this function is virtual. So this function also becomes virtual in all derived classes automatically. Okay. So the program output is now this one. If we recompile, when we recompile with the updated version, we will get this one, and this type of behavior is known as I mean dynamic polymorphism. The term polymorphism, well, that is understandable, but it demonstrates the polymorphism by passing objects to the graded activity and pass fail exam classes to the display grade function. So basically what was happening, we have the graded activity, and the graded activity had the letter grade class, I mean letter grade function. Now the graded activities implementation, let's see, let's take a look. What was the graded activities implementation? So you had multiple hierarchy there, but there is, I mean, this function is virtual. That means you have all the way it is virtual. I mean, during its derived classes, it will remain virtual. Now, if we see, let's see, just a second. So you, what is going on? So if you look at here, the main function in this case, where did it go? Here. So the main function in this case here. So you have the grade and you have the graded activity. Now you have the pass fail activity test and then you do the test score. Now the display grade is posed to, I mean, this is the activity, it's the graded activity. So, uh, so graded activity, I mean, display pass fail activity is a display graded activity, but since the graded activities character, that function is basically virtual, so it is passing its right. I mean, this one, you see, this is the parent class. If it follows the static polymorphism, then it would print this one according to this one, like C, it will print C. But you know, it is virtual, so it is transferring its right, its ownership to its next class, I mean next class in the hierarchy or its child class. So you see here, uh, here we have this virtual, it is also passing it over, but this is the function which is called. So you can see here pass fail activity here, and you can see the later grade is determined here. So since it is virtual, that is why even though we are referencing it as a graded activity class, we are still displaying the one attached to the pass fail activity. So basically, although I mean the graded activity class originally implements this numerical, I mean this letter grade function, get letter grade function differently, it is not accepting that one because it is virtual function and it is at the runtime, it is picking up the function, the child class, rather than the parent class. In the previous case, since we were referencing the parent class, it was literally picking up the parent class only, not the child class. So that is the difference. So by means of the word virtual, it is picking up the uh, the the other one, the one that is really intended, the one you are executing, the class that you are executing correctly. I mean currently. So that's your basically that's the implication of your virtual function. Now you could have written it in this way as well. I mean you can I mean before we have written, let me, it is doing it in a different way. So if you see it here, I mean, not, is it the one we are trying to show? No, not this one. We were trying to run it here. Let's, yeah, here. So, I mean, in this way, in this case, you know, uh, we have this type of this, we are instantiating the pass fail activity. But if you just do it the other way, like if you try to instantiate using the graded activity here, for example, and then you do, I mean, this is the main function, another main function, I would say. It's not the one we wrote or we called, it is another main function. And then you have pass fail exam, you have the test 2, I mean, the another test, I mean, for example, you have test 1, you have the test 2, I mean, basically, you are calling the two instances of the test. Now, if you display the grade, then your results will be little different. I mean, for this one, it is quite obvious you are calling the graded activity and test one, and then if you display the grade for test one, you will see the letter grade. Why? Because your graded activity class implemented the letter grade class or get letter grade function uh, differently. I mean, it was differentiating between A, B, C, D, etc. But your pass fail exam by definition does not implement this class. So it will pick up the one it is implemented from. So basically, you can see here. Let me again bring it up the the code. So pass fail exam, you see here letter grade, it does not contain great letter grade, but it is inheriting that from the pass fail activity, and the pass fail activity has not this one, this is not the one we want here. Pass fail exam, it does not have any get letter grade, but pass fail exam, pass fail activity does have. So this one, this is a virtual function, but it's implemented pass or fail. So basically, when you instantiate pass fail exam object, then you expect that it will be driven by the pass fail activity, because this is the one where it is implemented, which is being implemented here. And this is also virtual, but this function is itself called. So when you see that you are calling just you are calling this graded activity, which is where you have different A, B, C, D grade, then you expect this one to be reflected A, B, C, D, whatever grade it is. And whenever you do it here, you expect that it will be consistent with pass fail activity, which is pass or fail, that kind of grading. So if you display the grades here, you will see for test 1 it is associated with graded activity, therefore it is B because it has differential grade. But test 2 is instantiating pass fail activity, means pass or fail grade, so that's why it is doing the P. So earlier we are having the problem because we have seen that even though we instantiated the pass fail activity, since we reference the graded activity when we call the function, it was basically printing the pass fail score only, pass fail grade only. So that was because static polymorphism, but here we are using it virtual, I mean virtual function. So it is flowing through the runtime. So that's why you see it. I mean whichever class is called, you see the manifestation instantiated, you see that particular uh, that particular implementation you can see. So not the one you reference here. Had it been static polymorphism, it would go by this one, whatever reference it possesses. But it's not static, it's dynamic. That's why it is um, following the one it is actually uh, coming from, that is the derived classes. So here it is a parent class, so that's why it is ABCD grade, but here it is a derived class which has the pass or fail grade. That's why it was getting pass and fail grade. So the polymorphism behavior is possible when an object is referenced by a reference variable or a pointer. So you can see here in the code. So this is basically referenced by a pointer, or I mean not pointer, it's a reference variable. So polymorphism is only possible. Always remember that it is impossible without an object being referenced by a reference variable or a pointer. So that is important. Having a reference variable and pointer is essential to display polymorphism. So the base class pointers can define a pointer to the base class object. That's what it happened here. This one is a base class pointer. It can assign it the address of the derived class object. Okay, it can assign, I mean, the base class pointer can assign it the address of a derived class object. So here, for example, if you use the pointer, I mean, not the reference, if you use the pointer, you can see graded activity pointer exam equals new pass fail exam. So this one is pointed to the memory location of the graded activity, but you know, um, we are defining a pointer to the base class, but you can assign it, it can assign the value, assign the address of the derived class, which is this one. So that is one of the things that you see in the polymorphism. Like if you have an animal object and you have a dog, a cat inherited from it, you can always say animal A, this is a pointer, equals new dog. And that is normal because of course dog is an animal. That's what is happening here. So base class pointers and references um, only know about the member of the base class. Of course it should. So you cannot use base class pointer to call a derived class point function. So um, you can just do that. I mean, if you have more function in the derived class, but you use a base class pointer, of course you cannot call the derived classes functions or methods. Now, redefined functions in the derived class will be ignored unless base class declares the function virtual. So these are the rules. Always remember that if it were the static binding, then it would be otherwise. I mean, like if you don't mention the word virtual, then whenever you use the base class pointer, everything is about base class. But if you use a virtual notation ahead of a function, then it will use the function in the derived class if that is available. Now you can see the redefinition versus overriding. I mean, in C++, redefined functions are statically bound and overridden functions are dynamically bound. So a virtual function is essentially overridden. There are two things, redefined versus override. Redefine means you are basically rewriting the function. So it's a static way. You are erasing the function from the life cycle and write a new function. Whenever you instantiate a um, derived class, that means you are not, and there is a static binding. That means your previous function is not in scope. But whenever you have the virtual function, you are overriding the one. That's why it comes, I mean, that's why whenever you define it, instantiate whatever class, I mean, if you instantiate a derived class and use a pointer to the, still use a pointer or the reference to the parent class, it will still refer um, to the uh, to the derived classes function because that function is overridden. I mean, it's rewritten. So in the previous case, you have two functions. One is with one class, another is with a derived class, and one is with base, another with derived. You instantiate derived, everything is derived. And but then you suddenly you start using a reference to your base class and then you start to see the behavior of the base class. So but in this case, in the case of dynamic polymorphism, you are overriding, you are just rewriting the things, you are changing the things. So that's why you are I mean, even though you are pointing towards the base class's definition of function is no longer valid because we already have a overridden version of the same function. So you can have a destructor which is virtual. It's good idea to make destructors virtual if the class could ever become a base class. Otherwise, the compiler will perform static binding on the destructor if the class ever is derived from. So you can see that particular example. I don't want to go into there. Um, I mean, there is a final, there is C++ 11 versions. This is the version of the C++. This override and final keywords. The override keyword tells the compiler there is a way you can use the override keyword. That's what we are going to show next. And when a member function is declared with the final keyword, it cannot be overridden in a derived class. This is very important. I mean, so far, before C++ 11, this behavior was observed in Java. But now with C++ 11 version, it is also, you can find the final keyword, and final keyword basically imply that you cannot override that function that is final. So if your function that we have used here, like this one, say here, if it is a final function, you could not override it. So does that mean virtual and final cannot stay together? Think about it. So so that's our override, and so we are talking about the virtual destructor and then final functions, final keyword. So you can also have abstract base classes and pure virtual functions. How is that? A pure virtual function is a virtual function um, that must be overridden in a derived class that has objects. So it's a contract. A pure virtual function is nothing but a contract. So whenever you say a virtual, whenever you say it's virtual, then you must override it. An abstract base class contains at least one pure virtual function. So a pure virtual function looks like this. The zero indicates a pure virtual function. Whenever you say equals zero, that means it's a pure virtual function. So equals zero indicates a contract. It's a contract that between the parent class and base class, if a parent class has a pure virtual function equals zero, that is the notation, then this virtual function must be overridden within the derived class. Now you can define an abstract base class. How do you call it an abstract base class? The If it contains at least one pure virtual function, then only it is abstract base class. Now the abstract base classes must have no function definition. I mean this one, I mean whenever you have a pure virtual function, you should not have any virtual function definition. You should not implement that in the base class itself. Then it no longer becomes a pure virtual function. You will get some compiler issues probably. Just test it. So abstract base class is a class that can have no object at all because you cannot instantiate an abstract base class. Why? If you can instantiate a class into an object, then you should be able to use this one. Why? But you cannot use y because it's pure virtual function. There is no concrete implementation of this function. So then you are going to nowhere. So that's why the compiler defines, I mean makes the life cycle of the class in a way that abstract base class cannot be instantiated, never ever. Now it's a serve as a basis for derived classes. So when do you use an abstract base class? Suppose you have some behavior intended for any object or any class that extends or that implements the base class. So let's say you have, let's say the following situation. Let's say you have a class that has a database connection. Let us have a class, abstract base class called database connection. Now if you make it an abstract base class, all functions are virtual, at least one of them are virtual. That makes it uninstantiable. So if you make it an abstract base class, and then suppose what are the functions you can have there? Let's say create connection and clean connection. Let it be there. Let there are two functions, create connection. So uh, we have an abstract base class. So let's say database DB. I'm just writing in an abbreviated way, and you have two functions called create and clean connection. Now, what does that mean? Any class that implements the DB class must have a create connection and clean up connection function. So that becomes a contract, because if someone inherits, so then the DB, maybe the credentials, the function that implements the credential, that function may be a concrete function within the abstract class. Create connection can be an abstract class. So no, sorry, that can be a real concrete function, but the other one, the clean connection, is a virtual function. What does that mean? It means that you have to whenever you extend or you implement that base class into a child class, you inherit the create connection, but you must override the clear connection, because clear connection may have different clauses, different error messages, depending on whatever your client is, whatever function you are implementing it into. So C++, another thing in the C++ is called multiple inheritance. A derived class can have more than one base class, and that is very annoying. You know, each base class can have its own access specification in derived class definition. So class cube can be, I mean, this is a derived class. It can have two different um, base classes, square and rectangular solid, whatever. So it's very, I mean, in Java, for example, this is not allowed, but in C++, this is allowed, and that therefore we have to be very careful about using the multiple inheritance. So arguments can be passed to both base classes constructors. So you can do that. I mean, you can pass, you can define the constructors as whatever way. Now, base class constructors are called in order given in class declaration, not in order used in class constructor. So the way you define it in the class definition, class declaration. So basically that means that if you have this, the constructor will be called in first this constructor will be called, second this constructor will be called. It doesn't matter which one you call first, which one you call second in the constructor itself. So basically it will follow the order of implementation here. This will be one, this will be two. Now the problem is what if base classes have member variables functions with the same name? The solution is derived class redefines the multiply defined functions. Derived class invokes member function in a particular base class using the scope resolution operator. Then you say which one you are using. Then you can write the class name and then double colons. That is the scope resolution operator. There can be a compiler error if derived class uses base class function without one of these solutions. So suppose you have A that implements B and C, and then B has a function called X, C has a function called X. So in the A, you should use like in the function X, you should specify which one you are going to use. X or C scope resolution X. So that is important. So that's, I think that's about it. I mean, we discussed a lot of, with lot of examples, the inheritance. We came to the end of the inheritance, but there can be more questions in the inheritance. I mean, for your understanding, like there can be a problem called diamond problem in the inheritance. I am leaving it for you to do a little bit research, and maybe I will put together an extra credit assignment related to the diamond assignment and diamond operator next week. So you learn these slides, you do the problems, then I can give you um, some assignment related to a diamond problem related to the multiple inheritance in C++, and that will be a great thing to learn because that's very favorite questions for any interviews, job interviews that involves any object oriented programming. So we will be working on that. So basically you can google it and you will find it in all good places like Stack Overflow, or let's say uh, some Geeks for Geeks. Those websites you will find definitions of the diamond problem and why it is a problem, what is the problem, and why it is called a problem at all, and how to solve that problem. So we will, I mean, of course, I mean, we can have a brief discussion as well in the beginning of next week, but otherwise, I think that is it for today. Do you have any questions for me? As always, I mean, if you have questions, you can send me an email or you can ask me for a meeting. Like, of course, there is an office hour, but beyond that office hour, I mean, we can set up a meeting, set up a call, and talk about it. Ultimately, it's up to you to learn the topic. I can explain a lot of things. I can try to explain a lot of things, but it's up to you to digest and then convert it into your capability. So uh, don't feel free to ask questions. Okay, thanks for attending the class. It's nice to have you in my class, and also don't forget to submit the assignments. That's very important as we have already crossed the midpoint of the course. So I will be setting up the due dates for the assignments moving forward. And the previous assignments will also get a due date. Let's say, I mean, I will not give the same due date all on a sudden for everything, but it will come. I mean, in general, everything will be available until June 3rd, June the 3rd, and that date is very hard because of the school's policy. So we cannot change that date. So keep in that mind. So that's about the assignments. So yeah, I mean that's it. Unless you have any questions, then talk to you next week. Thank you so much.